Hello, my name is Avcı.
Hello, my name is Ecem Özbek.
Hello everyone, my name is Noyan Soylu.
The name of our project is Assistive Image Captioning System for Visually Impaired People, and our supervisor is Dr. Nalan Özkurt. Today we are going to present our project design report, and we have divided this presentation into 4 parts. These parts are scope of the project, design, project management, and lastly, the experimental procedures and tests. Now let's begin with the first topic, which is the scope of the project. Visual impairment is a challenge in life that so many people suffer. According to World Health Organization, there are 2.2 billion people who are diagnosed with blindness and visual impairment. The visually impaired people encounter lots of hard things in their daily life. The most important challenge they encounter is not being able to pass safely the obstacles around the streets. This project aims to develop a system that can execute an image capturing algorithm by using an electronic glasses with the addition of a camera and a speaker for helping visually impaired people to let them know the environment. Now let's move to the second part of the presentation, which is the design part. The system of this project executes an image capturing algorithm to provide sufficient information about the environment to visually impaired people. The items that are needed to create this prototype are firstly, an electronic glasses with an IP camera for capturing the input images and sending them to the system by Wi-Fi. The second one is the computer for the execution of image captioning within Python. The third one is the Bluetooth speakers for sending the text-to-speech output to user. Our main performance target is to have all the components working properly. And also there are some performance evaluation techniques like Meteor, BLEU, CIDR, etc. These performance metrics have different calculation methods for defining the performance of output captions. Now let's look at the high-level design of the complete work. In the first step, the captured images are sent to the system by Wi-Fi. Secondly, the features inside the image are extracted. Thirdly, the extracted features are used by natural language processing model to create complete caption of the image. Lastly, the output caption is translated from text to speech and the sound is sent to the Bluetooth speakers. The aim of this work is to let user know the possible obstacles like in these images. From this point on, Ecem Özbek will continue the presentation.
Thank you, Noyan. I will talk about the item design of this project. Then I will explain image capture and transmission through Wi-Fi. We are going to purchase the glasses as a team to have prototype glasses as illustrated in figure 3. The assistive glasses has 5 megapixels with a video recording 1920-1080 HD resolution. It is better lifetime 70 minutes continuous recording after full charge and 64 hours standby time. Glasses has 8 GB micro SD card inside, but it supports a maximum 32 GB micro SD card. The glasses easy to operate and it is very lightweight. If needed, we are going to purchase the headphones. The aim of this project is image captioning. Convolutional neural networks, one of the artificial neural networks used for deep learning, was used in Assistive Image Captioning System for Visually Impaired People project. Each item employed in convolutional neural network CNN system are described in following figure 4. In this section, I would like to briefly talk about the layers of CNN. The functions of CNN layers are explained in detail in the design report. As shown in figure 5, CNN consists of 5 layers. Convolution is a class of linear process. CNN models is used in areas such as recognition, classification, and analysis of visual data such as images and videos. CNN performs the classification and labeling process thanks to its many layers with different tasks. First layer is input layer. In this layer of the CNN, the data are given in raw structure to the network. Convolution layer is the second layer that handles the image in the CNN algorithms. Images are actually matrices consisting of pixels with certain values. In the convolution layer, a filter smaller than the original image size hovers over the image and tries to capture certain features from this image. Rectified linear unit layer, that third layer comes after convolution layers. The layers is recognized also as layer of activation. The effect it has on the input data is that it pulls the negative values to zero. The fourth layer is pooling layer. The pooling layer also aims to reduce dimensionality. In this way, the required processing power is produced and capture unnecessary features are ignored and more important features are focused. There are three different kinds of pooling layer. These are max pooling, sum pooling, and average pooling. Max and average pooling are generally used in CNN model. Fully connected layer is the normal flat feed forward neural network layer. In one layer, it binds neuron to neurons in other layer. This layer depends on all areas of the previous layer. With the layers that are entirely interconnected, these features are combined to form a patterning. Finally, their output is cat, dog, car, truck, or etc. Now I would like to explain the neural language processing, recurrent neural networks, and long short-term memory. Natural language processing (NLP) is a subsection of computer science and linguistics, where studies are carried out on computer processing of texting or sounds in natural language. Recurrent neural networks are a type of neural networks that allow the input of previous output while allowing hidden states to be used. Typically, RNN can be represented like 12. Figure 13 shows the RNN flow diagram containing a single tonnage layer. All recurrent neural networks are a group of repetitive models. Are shown in figure 14, the four interactive layers that their own specific connection. RNN includes only one layer. The structure of LSTM is also have the repeating module in their structure. However, the structure in LSTM is different. Instead of one of network layer, the LSTM contains four of them. While RNN calculates by taking past information into account, the calculation process takes a long time and has difficulty accessing long-term information. LSTM, that a type of RNN, is used to eliminate the difficulty of accessing past information in RNN. I would like to give information about the main subject of this project, image captioning. With the use of CNN and LSTM, the generation of the captions from images are possible. The aim of image captioning is to the generation of the sentences automatically with an image input. Each performance metrics have their different evaluation methods and formulas. As seen above figure 15, there is an evaluation done by three different metrics on a program where MS COCO data was used. In the image captioning model figure 17, several images are taken from a video depending on the specified time interval. This image passed through the CNN part and the mean pooling was applied. In the next step, LSTM, that a kind of RNN, aims to express the image taken from the video in a few sentences. After LSTM process is text to the speech conversation module, sentences with LSTM output are converted to sound with text-to-speech tool. We are going to use Google's text-to-speech tool. Now, Öykü will continue.
Thank you, Ecem. I will talk about the realistic restrictions and the condition in the design. In this project, International Organization for Standardization, TC 173 standards will be used as a guide. The primary objective of TC 173 is to produce standards in the field of assistive products and related services to assist a person in compensating for reduced abilities. The glasses design will allow visually impaired individuals to fulfill their daily needs without needing an external assistance. This glasses model will help the individual perform their daily activities in an easier way. The visually impaired people can merge into society. The number of visually impaired people increased due to their health problems and their life circumstances. With assistive glasses technology for people who suffer from visual impairment, the health quality will increase with early detection of the obstacles. By detecting these obstacles that are from the streets in daily life and by warning with sound through the headphones, the individual can stay safe and they live their normal life without needing external help. With obstacles detection, the individual safety can be increased by decreasing their life risk. We mentioned details of the other aspects in design report. Let's move on to third part of this presentation, and that is experimental procedures and tests. Transmission of the pictures from the glasses to the computer. When the IP camera on assistive glasses is active, the images are recorded in a video format. Images are taken from the video at certain time intervals. These images are transferred from the glasses to the computer with Wi-Fi. Creating a caption from the image from the algorithm. Images imported to the computer are primarily processed in layers of CNN section. Object detection processing occurs in a convolutional neural networks. Then images are expressed in a few meaningful sentences with LSTM. In this way, the captioning process with LSTM is completed. Text-to-speech usage. After getting the caption of the image, the next step is to use an already existing text-to-speech program, or basically convert the text-to-speech within Python. Transmission of the sound. The sound will come from the text-to-speech will be heard from the speakers, which the user will use. The Bluetooth connection and the understandable sounds are important as the final steps of the execution of the system. System tests. We test the system by testing the whole prototype by getting images and transferring these images to the caption and these captions to the sound and final to the headphones. Field tests. After testing the system in home, we will test the system in streets and capturing images from the real-life video. Let's look at the fourth part of this presentation, and that is cost analysis. We will purchase the glasses from one of the international websites after a detailed search. The prototype does not need any professional equipment or environment. Testing can be done in proper home conditions. As a whole team, we will work 1 to 2 hours a day to finish the project. The assistive glasses is much better and usage much more convenient than other assistive glasses in the market, if it is compared as a cost and design aspect. Next, I would like to look at the final point today, risks and propose actions to minimize their effects. Hardware-based. The problems that might happen, such as the glasses might not work as expected, and the glasses can arrive very late. To minimize this effect, solution will be getting an IP camera. That IP camera can be combined with glasses or a headband. Software-based. The use of image caption is very efficient with Python. However, the problems can happen, such as the training of CNN might not work and some confusing errors might be seen. To avoid these issues, the solution will be using MATLAB rather than using Python. This is the references list that we used. Thank you for listening.